Okay, so we're going to be looking at computing some geometric series now. Uh, so here we have as our first example, the series as k goes from 0 to infinity of 1/4 times 3/5 to the k. So we recognize a is 1/4, and we recognize the ratio as 3/5. The ratio, the absolute value of that is less than 1, so we know this will converge. And so this one's set up and ready-made. We just plug in our formula. This is a, which would be 1/4, divided by 1 minus the ratio, 1 minus 3/5. So that would be 1/4 on top, divided by 1 minus 3/5 would be 2/5. So that would be 1/4 times the reciprocal of 2/5, which would be 5/2. And so we end up getting that this thing is going to converge to 5/8. Okay, this thing is going to converge to 5/8. That was a whole lot easier than finding the 20th sum that we were doing earlier when we did this same underlying sequence. Right, we're finding the 21st sum of the first 21 terms, which is approximately 165, which is actually what the actual limit of the infinite series is actually 0.625. So, but this is a lot easier. As I said, it's much easier to compute geometric series than it is to convert or to compute infinite series. Okay, so pretty basic, straightforward first example there. What's going to cause us problems with these geometric series problems is when the starting index is not 0. It starts at some other value. That's when we can have a little bit of problems. But I'm going to show you how to deal with that, and we'll address that in some upcoming examples.